So now we have a very interesting question which is based on okay. See, some of the standard textbooks classify this under the topic loss of motion. Some others put this under the topic rotational motion, uh, which actually, sorry, no, sorry, not rotational motion, under circular motion. Uh, but see, the reason why I have chosen this question to be in loss of motion is because this comes under the concept of friction, which is exclusively discussed in loss of motion and not circular motion. However, this includes both the topics from circular and circular motion and loss of motion. Okay, so before I go any further, I have a question for you. I written it over here. When a coin is placed on a rotating table, it stays and it slips. You will complete this equation. Okay, the relationship between F static and F centrifugal. Is it less than, or is it greater than, or is it greater than, or is it less than? Okay, so that's what you have to do. Okay, now if you know the answer, you can do that directly. Now, otherwise, what I would suggest is instead of going through this solution here, now those who want only the solution, you have it written over here, right? You can do the substitution and you have the answer then, direct answer then. But otherwise, I would request you to spend a couple of minutes more, or maybe more than that, to understand the concept of static friction, the limiting value of static friction, the angular velocity, relationship between angular velocity and angular acceleration, and all of this totally linked to the loss of motion here. Okay, so to make you understand that, what I've done is I've taken, uh, I've taken three diagrams here. Please give me a minute. Okay, so not three, we have four diagrams here. So what is this? What is this diagram depicting? See, we have a table at rest, and there is a coin placed on the table which is also at rest, which means I'll have to add it over here, table and coin as well at rest. Okay, now see, this comes under the classic problems in mechanics, which we call as the turntable problems, right? Turntable represents table which has a fixed base, a support, and then it rotates the disc on the support. Okay, so excuse me. So what we do is now we rotate this disk or rotate this table with some velocity. Okay, and what happens due to inertia, since this coin is placed on top of the disk, as the disk rotates, the coin will also rotate. Now, how many? Please don't be carried away these diagrams here. Please make sure that you focus on the diagram here. So, when this coin is rotating, what happens is this coin will acquire all the properties with respect to velocities as that of the table, right? Now we know that whenever an object is executing angular motion, there will be one component which is always perpendicular, which is always perpendicular, which is always perpendicular to its motion, right? So that is the velocity component V here. All right. Now there is another component which we call it as a centripetal force, which will act always radially inwards. Centripetal force will always act radially inwards, right? So these are the two components which are present, these are two forces, or one velocity and one force which is acting upon exactly the coin which is placed on the table. Now, for higher values of v, what will happen? For higher values of v, we know that the velocity vector, this vector would be larger, right? And the centripetal force which is acting towards the center will remain the same here, right? Okay. Now, for even higher values of v, what will happen is at some point the velocity vector would overcome this centripetal force, right? Or rather, the motion due to the linear velocity will overcome the angular velocity, right? I hope this much point is clear. Okay. Now let's try to understand the mathematical representation of whatever we have said so far. See, velocity of coin is equal to velocity of table, which is equal to 0. Am I correct here? Right? If this is correct, tell me what is the velocity of coin with respect to velocity of table? Exactly. It would be Vc minus Vd, which is actually equal to, let me use a different color here. Okay, which is actually equal to 0 minus 0, that is 0, right? Now in the second case, what is velocity of coin with respect to velocity of with respect to table? It is velocity of coin minus velocity of table, and since both of them have the same velocity, it will be omega 1, not the angular velocity. I'm just giving some random value here. So omega 1 minus omega 1, which is equal to 0. So the relative velocity in both these cases, what is it? It is equal to 0. Let us see in the third case. What happens in the third case? The third case, velocity of coin is equal to velocity of table is equal to some other value omega 2. We're talking about higher values of v. And what is the relative velocity here now? This actually will be equal to omega 2 minus omega 2. Therefore, velocity of coin with respect to table again remains 0 here. Right? Now let us see for very high values of v. What will happen for this very high values of v? We need to understand that at some point of time, okay, now let us say at some point of time, this velocity would result in this velocity would result in the coin being displaced from the table, right? The coin will now be displaced from the table. Let us say the coin has reached this point. The coin has reached this point. The coin is no longer here. The coin is no longer here on the table. It has left the table, right? The coin is moving away with some velocity. Okay. Now the coin is moving, has left the table. It is moving with some other velocity, right? Let us call that as L3, velocity as L3. But the table will still now be rotating with velocity V3. And now if you see, velocity of coin with respect to table is actually equal to L3 minus omega 3, which is definitely not equal to 0, right? What are we talking about? Relative velocity of coin with respect to table. So in the first case it was 0, second case for 0, so smaller values of v 0, higher values of v, relative velocity is 0. For even higher values of v, at one point when the coin bounces off the table, the relative velocity is not equal to 0, right? Okay, and it is at this point that we say that the coin has slipped. It is not the essential or the literal meaning of slipping. No, slipping means, see, this is one of the primary concepts where students always make a minute not detailed understanding of the words given in the question. Slipping means that there is some relative velocity, which when I say some, it is not equal to 0. Relative velocity between the coin and that of the table. I took a long time to explain this, but I wanted you to visualize the concept here, because see, if you don't visualize things, you won't be able to make your concepts clear. All right. So what does it mean when the coin has slipped? It means that there is some relative motion between, there is some relative velocity between the coin and the table. All right. So that was about slipping. Now let us slowly bring in the concept of friction. Let's see what happens in the case of friction. Okay, maybe I should keep this part. Oops. Excuse me for a minute. Yeah. So now let us try to understand what happens with friction here. See, when the table and the coin, both of them being at rest, there is no concept of static friction, right? Because static friction is at rest. But when there is an external force applied and when the table is rotating, static friction will come into picture. For low values of v, the static friction, we know that the value would be less than or equal to mu s into n, right? Now, as the values of velocity becomes higher, what will happen? Static friction value will be more than the static friction value in the first case. So SF2 will be greater than SF1. But even in both these cases, the static friction value will be either less than or equal to the mu s into n, right? But as soon as the value of static friction is greater than mu s into n, what will happen? Exactly. What happens is the relative velocity between these two bodies will come into picture, and as a result of which there will be slippage of coin. Okay, so what I've done is I have showed you what slipping of coin is. Then we discussed in detail the relationship between slipping of coin and that of coefficient of friction and, for that matter, static friction. Okay, right. Now what I want to do is I want you to visualize this concept here. I'm not going to derive things in detail here. Because it's okay now. I think it's almost close to 10 minutes, which is more than the normal value, normal than time we use for discussing problems. However, these kind of concepts, these kind of questions enrich your understanding about the question, the concepts, and that's why I'm trying to try to give more emphasis on the problem here. Okay, so what I've done is earlier we were discussing one circular disc and one coin on it, right? In this case, I have taken one circular disc and two coins. One coin which is at a distance r1, the other coin which is at a distance r2. From where? From the center of the table. All right. So we have r1 and r2. So first step of the solving the problem, which is, okay, maybe I should keep that flowchart as a reference because some of you will repeatedly be asking about the same thing. Maybe I'll do that now. Okay, so this is the flowchart here. We need to first visualize it. Frame of reference. As usual, I'll stick on to the inertial frame of reference, which means the observer is standing out from the from wherever this picture is happening. Then a system. We have the system, which is the disk and the coin. Isolate the body. Isolate the body. Isolate the body. The body is isolated here. Then sigma of x, sigma of y. We have drawn n1 mg, n1 m1g, n2 m2g. Now, what is sigma fx? Sigma fx will be equal to m into an. What will be sigma fx? Here it will be m into n. Same in the both cases because both of them are on the same table. What will be sigma fy? Since there is no vertical motion, I repeat, since there is no, which means the coin is not lifting, it is not getting lifted into the air, it is not thrown away into the air vertically. It stays, whatever motion it follows only along the horizontal motion. And there will be one force acting like this, which will be the friction force. There will be one force acting like this, which will be the force of friction, right? And then I think the rest is already been explained in the first part. As velocity increases, value of frictional force increases, velocity increases, value of frictional force even increases. But at some point, when the velocity increases beyond the force of static friction, the coin slips. Okay. Now what you can do is you can do both of the comparisons and tell me what will be the relationship between these forces when okay, wait. I think it's better. That if you make a note of this, you can complete this, and we will discuss this in detail when we see the given question. Yeah, that would be better because that comprises of even the discussion in even better detail. Give me a second. Let me just minimize this thing, right? And we will. Yeah. Okay. So now coming back to our question here. All right. So according to the question, we've been given two different conditions, right? We've been given two conditions. What is condition number one? Condition number one is that it is placed at a distance of 1 centimeter. What is condition number two? Okay, sorry. Both of them are placed at a distance of 1 centimeter. Is it? Distance of 1 centimeter from the center. The angular velocity will be the distance of from center. Yeah. So the second condition, R2 is not equal to R1. There is some displacement from R1. Okay. Right. Now, what we'll do is we'll try to understand the various forces acting on it. See, again, the flowchart as you asked is really important here. We visualize the concept with the question, and now we'll introduce the free body diagram. Now, what's the free body diagram of first case? So we have a coin here, table here. The coin is rotating like this, which means definitely there will be F centripetal acting along the x direction, right? And what does it mean when sigma Fy is equal to 0? sigma Fy is equal to 0 implies that n will be equal to mg, right? Now, what I want to do is the previous discussion when we wrote R1, R2 and coin 1, coin 2, I wanted to extrapolate the same discussion, same derivation over that. Okay. Now, I'm not going to do that because that's not a point of discussion here. Okay. Now, what is sigma fx? Sigma fx is equal to m into a m into a. Let's say m into a. What a is here? Is it linear acceleration? No. Why? Because the circular motion, that would be a centripetal, right? What is a centripetal? A centripetal is v square by r. So what is sigma fx is equal to m into v square by r. Now, what is sigma fx? All the forces acting along the sum of all the forces acting along the x direction. So there is only one force which is acting along the x direction, which is the f centripetal, right? So we have f centripetal is equal to mv square by r. Come on, this is something very basic to circular motion. But why are we discussing that in laws of motion? Because this circular motion over here is taking place due to the centripetal force, which is actually a name that we give to a pre-existing force, which is nothing but the force of friction. So what is the centripetal force here? Centripetal force here is nothing but the force of friction. I repeat, what is centripetal force? Centripetal force is nothing but the force of friction. So we can replace F centripetal with the force of friction. And which friction is acting here? Now things become really conceptual here. It is not the kinetic friction. It is rather the static friction, right? Because the coin is still at rest. And now we have F static replacing F centripetal. So what is F static? F static is equal to mu s into n. And what is n? N is equal to mg. So we have mu s into n is equal to m into v square. What is v square? R. What is v? V is r omega. What is v square? R omega the whole square. So what we get is mu s into n is equal to m into r omega square. And if you do the same thing for the second, for the same coin, capital distance r2, what you get is mu s into n is equal to m into r into omega square. Okay. Yeah, now you may be wondering what is the difference between these two. The difference between these two is that the angular velocities is different. So this is actually omega 1 square and this is omega 2 square. However, what remains same is the value of mu s into n. Why? Because in both the cases, mg is same because it is the same coin which is kept at two different positions. Therefore, mu s into n and mu s into n would be same here, which means mr omega 1 square will be equal to mr omega 2 square. And if we see, m and m will be same, r and r will not be same. It will be r1 and r2, right? So we have r1 into omega 1 square is equal to r2 into omega 2 square, but it is given that the angular if the angular velocity is halved, so we can say that omega 2 is actually omega 1 by 2. Therefore we can say that r1 into omega 1 square is equal to r. Instead of omega 2, what can I write? Omega 2, I can write omega 1 by 2 the whole square. Therefore r1 into omega 1 square is equal to r2 into omega 1 by 2 the whole square. And therefore this becomes r1 is equal to r1 is equal to r2 into, so this is omega 1 square into omega 1 square by 4. Omega 1 square by omega 1 square is 1. And therefore what we get is r2 is equal to 4 times r1. And what's the value of r1? It is 1 centimeter. So this becomes 4 into 1. And therefore the value of r2 is 4 centimeter. So r2 is 4 centimeters. It's a lengthy explanation, I do understand. But the reason why I made it so lengthy is to make sure that you understand, number one, what is slipping of coin. Number two, relationship between slipping and the friction. Then static friction, kinetic friction, and then understand relationship between centripetal force and friction here. All right. Okay. So yeah. A bullet of mass 0.1 kilogram moving horizontally with a speed of 400 meters per second hits a wooden block 3.9 kilogram kept on a horizontal rough surface. The bullet gets embedded, moves 20 centimeters before coming to rest. Coefficient of friction between block and the surfaces. Okay, So we have a bullet, right? What's the mass of it? The mass of this is 0.1 kilogram. It's moving horizontally with a speed of 400 meter per second, gets embedded into 3.9 kilogram. It moves 20 meters, right? Okay, so it moves 20 meter before coming to rest. See, we'll visualize first, that is this process, but not completely. We need this one also. And let's choose the frame of reference to be inertial frame. So we will visualize things from this point over here, okay, outside the frame. Isolate the body, we will isolate this body, and then sigma fx and sigma fy. Let me just remove this portion from here. Okay, now let's try to understand what's happening using the diagram here. See the diagram, I've taken two sets of diagram, okay. So the first set would be like this. Okay, and what's happening in step 1? Step 1, 0.1 kilogram bullet with 400 meter per second is embedding into 3.9, and here I will consider the system to be, bullet and the block. So what is the system here? The bullet and the block. So this dotted line represents the system. Excuse me. So what we have here is the initial condition. What is initial condition? By initial I mean before what? Exactly before collision. And by final condition I mean after collision, right? And between this initial and final conditions, that is between before and after collision conditions, we know that the net external force acting on it is 0. And if net external force is acting on it is 0, then we know that by force impulse momentum theorem that the change in momentum will be equal to 0, or in other words we can say that the initial momentum will be equal to the final momentum. The initial momentum refers to before collision and final momentum refers to after collision. In initial momentum, which is before collision, we know that there are two components, therefore the equation will have two components. One is the bullet whose, okay, maybe I can write it down one more time. So we can say mass of the bullet into velocity of the bullet, right? Plus mass of the block into the velocity of the block. Now it is given that wooden block of mass is kept on a horizontal surface. So we assume that the velocity is equal to 0 for the block, and mass of bullet is 0.1 gram, velocity of bullet is 400 meter per second. Therefore, what we get is velocity final is actually 0.1 into 400, the whole upon 3.9 plus 0.1 is 4, right? 400 into 0.1 is 40 by 4. Therefore, V4 is equal to 10 meter per second, right? Okay, now that we have this value of final velocity to be 10 meter per second, what can we do next? Now what we can do is we'll move to the second part of the problem, right? What is second part of the problem? After this collision, the bullet gets embedded. Yes, the bullet gets embedded, and then it moves 20 meter. So after this collision, the bullet is moving 20 meter, and finally it comes to rest. Therefore, the velocity here is actually equal to rest, right? And what is the initial velocity here? So if you come, let us say from this for the motion along AB, if you write this for the motion along AB, what is the initial velocity? The initial velocity is the velocity by which the system was moving after collision. After collision, what is the final velocity? The final velocity is equal to 10 meter per second. Therefore, initial velocity here is the final velocity earlier, which is 10 meter per second. And what is the final velocity here? The final velocity here is the object is coming to rest. Therefore, the final velocity is equal to 0. And if we use the velocity displacement relationship, what we get is v square is equal to u square plus 2as, and v is equal to 0. So 0 is, what is u square? U square now here would be equal to 10 square plus 2as, and therefore we have 0 is equal to 100 plus 2 into a is 20, so we get as 12, sorry, 20 into 2 is, wait, yeah, 20 into 2 is 40a, right? So what we get is a is equal to minus 100 by 4, which is otherwise equal to minus 25 meter per second square. Wait, am I making a mistake? Oh, yes. There's a 0 here, is 40, right? So it's 10 by 4 and gives us the answer to be minus 2.5 meter per second square, which is option. Okay, the options are not clear. It's option D here. So the retardation here is actually equal to minus 2.5 meter per second square. A block of mass 5 kg is placed at rest on a table of rough surface. Now, if a force of 30 Newton is applied in the direction parallel to the surface of the table, the block slides through a distance of 50 meter in an interval of 10 seconds. The coefficient of friction is. Okay. So, as usual, what we'll do is, we'll first visualize, right? And then find a frame of reference. So, this is the visualization. A block is for 5 kg is placed at rest on a table of, okay, rough. So this is a rough condition, something that I haven't drawn here, my bad. It's a rough condition. Okay, now if this is a rough condition, what will act on it? Yes, friction will act on it. Force of 30 Newton is applied parallel. Okay, it's applied parallel. It slides a distance of 50 meter. Okay, so now we don't need a question. Now what we need to do is directly the answer. So let's see. So the visualization part is done. Now we need a frame of reference. We will use inertial frame of reference as a person standing on a non-accelerating frame, right? And he's visualizing things from here. Okay. So visualization is done. Frame of reference is done. The system is done. What is the system? The system is this block here. System is done. Isolated body. We have isolated the body here. Then we have to sigma fx and sigma fi. So this portion is not required now. Let us now try to focus on the given portion, given conditions here. So we have 5 kg, 30 Newton. Okay, it is at rest. So since it is at rest, we can say that this u is equal to 0 here, right? And if u is equal to 0 is given, if u is equal to 0 is given, it is also given to us that the displacement is 50 meter in 10 seconds. So the moment you see displacement and time, what comes to your mind? Exactly your displacement time relationship, which is S is equal to ut plus half at square. What is S? Given to us as 50. What is u? It is 0 plus half into 8. What is t? T is 10 square, 10 square. So half into 8 and square is 100. 0 plus 8 to 10 square is, wait, I have a mistake here. No, I have taken this transposed 2 to the LHS. So 15 to 2 is 100. So we have 100 is equal to A into 100, and therefore A is equal to 1, right? So the acceleration is 1 meter per second square. Okay, having said that, let us now move on to the free body diagram. So draw the free body diagram of this body. What are the various forces acting on it? The very first forces would be the force of gravitation, which results in mg, and since it is on a surface, this surface will exert a force on the block, which will be normal reaction on the block due to the surface, right? There is one other force, 30 Newton, which is acting parallel, and since it is moving on a rough surface, we know that force of friction would act opposing the force of caution. Sorry, the force which is causing the motion. Now, you may have a doubt here, which friction are we going to consider? Is it going to be static or that of kinetic? No doubt about this, because since the object is moving with a significant velocity, we can directly say that the friction acting here is kinetic friction. Now, if we apply equilibrium condition. What is sigma Fy is equal to 0? What is sigma? Why is sigma Fy equal to 0? Sigma Fy is equal to 0 because body is not moving along the which direction? Body is not moving along the y direction. If the body is not moving along the y direction, therefore the velocity Vy is equal to 0, therefore Ay is equal to 0, therefore m into Ay is equal to 0, and therefore F is equal to m into Ay is also equal to 0. Therefore sigma Fy is equal to 0. What does it mean when sigma Fy is equal to 0? When sigma Fy is equal to 0, it means that forces along the up direction are equal to forces along the down direction. What is the force acting on the up direction? Only one force, which is normal reaction on the block due to the surface. Therefore, we can write N is equal to forces down direction. The only force acting along the down direction is mg. Therefore, N is equal to mg. Now, what is sigma Fx is equal to? Sigma Fx is equal to ma. Now, how many forces are acting on the x direction? X direction, there are two forces. One is the 30 Newton force and the other is the kinetic friction. And if we understand, if we focus more on 30 Newton kinetic friction, how do you identify the signs of it? What we need to understand is, what is the overall direction of motion? The net direction of motion is towards the right because the body is moving towards the right. The net direction of motion is towards the right. And therefore, what do we see? Maybe I'll just draw it one more time. This is the net direction of motion. How many forces are acting along it? There is one force of 30 Newton. What is the other force? The other force is the force of kinetic friction. All the forces which are acting along the net direction of motion would be taken as positive. All the forces which are acting against the net direction of motion would be taken as negative. Therefore, when you write down sigma Fx, you will have two components. One, 30 Newton being positive, and the other kinetic friction being negative, and what is kinetic friction is equal to? Kinetic friction is equal to coefficient of kinetic friction into normal reaction. What is normal reaction? Normal reaction is equal to mg, and therefore what we have is plus 30 minus mu k into n is equal to 5 into a. Now I hope I can just remove this from the board, right? Okay. Now we have 30 minus mu k is equal to, what is n? N is equal to mg, so this is equal to 5 into a. So we have 30 minus mu k, what's the value of mg? Should be 5 into 10, which is 50, is equal to 5 into, what is the value of a? We found out to be 1, so it is 5 into a. Therefore we have 30 minus 5 is equal to mu k times 50. What is 30 minus 5? It is 25. So we have 25 by 50 is equal to mu k, which is equal to 1 by 2. Therefore mu k is equal to 0.5. So what's the question? The question is coefficient of kinetic friction is here equal to 0.5. A body of mass 10 kg is moving with an initial speed of 20 meters per second. The body stops after 5 seconds due to the friction between body and the floor. The value of the friction is okay. So as usual, let us try to understand what should be the flow chart here. So we have a frame of reference, right? Well, ideally we should start with visualizing the given data, right? Visualizing and then choosing the frame of reference. So I have drawn a diagram to visualize things here. A body of mass 10 kg. Maybe I'll just enlarge it. Yeah. So a body of mass 10 kg moving with speed of 20 meters per second. The body stops after 5 seconds. So the body is moving like this. After t is equal to 5 seconds, the body stops, which means the final velocity here is equal to 0. So the moment we have this scenario, we can choose a frame of reference, which usually I prefer to choose non-inertial frame, right? So this is a person watching things from outside the system. Now, by velocity time relationship, we have v is equal to u plus at. Final velocity is 0, initial velocity is 20. A is not given, time is given to us as 5 seconds. Therefore, we can say that A is minus 20, 5A is equal to minus 20, and therefore what is the value of A? A would therefore be equal to minus 4, right? Now let us go to the selecting the body, which is this body. So we have the body here, and draw the various forces acting on it. The first force would be force of gravitation, which would result in weight mg acting downwards. Now, since the body is exerting an force downwards, being in contact with the floor, right? Being in contact with the floor, the body will receive an opposite force from the floor, which we call as normal reaction. So we have normal reaction on the block arising from the floor, right? And since it is moving towards the right, the net direction of motion is towards the right. And since the motion is towards the right, we know that friction will act. If the body is moving towards the right, then friction will be acting towards the left. But now the question comes up, although not mentioned in the in this given problem. The question here is, what kind of friction is this? Is this static friction or is this kinetic friction? Well, we need to understand the concept here. See, static friction and okay, I think let's do one thing. Let's wait for one more question. Maybe I'll just I'll detail the concept here. Here, what we need to understand is the friction is kinetic friction, and we'll in the next question we'll see how to detail how to differentiate both of them. Not here. So this is anyway kinetic friction here. The body is moving. This is kinetic friction. Now, if we apply sigma fx and sigma fy, sigma fx is equal to ma and sigma fy is equal to 0. Why? Because body is not moving in the which direction? Body is not moving in the y direction. Therefore, there is no motion in the y direction, and therefore vy is equal to 0. Therefore, ay is equal to 0, and m into ay is equal to 0, which implies fy is equal to 0. Okay. So yeah, that's it. But there is motion in the x direction, and therefore sigma fx should be equal to ma. What is sigma fx? Sum of all the forces acting in the x direction. How many forces are there in the x direction here? If you observe the free body diagram, there is only one force, a retarding force, which is kf. And how will you choose the sign convention? All those forces which are acting along the direction, net direction of motion, would be taken as positive. All the forces acting against the net direction of motion would be taken as negative, and therefore we will take minus kf is equal to ma. And what is the value of kf? Kinetic friction. Kinetic friction is given to us as okay, it's not given. We need to find the value of friction. Okay, so what is the formula for kinetic friction? It is mu. My bad. This is not mu s. This should be mu k. This should be mu k. So what is mu k into n? Mu k is equal to ma. What is mu k into n is equal to, what is n here? N from this equation. What is sigma y is equal to sigma fy is equal to 0 implies? All the forces acting in the up direction should be equal to all the forces acting in the down direction. So sigma fy is equal to 0 implies sigma of forces acting in the up direction would be equal to sigma of forces acting in the down direction. What are the forces acting in the up direction? The only force acting in the up direction is normal reaction. What are the forces acting in the down direction? The only force acting in the down direction is mg, and therefore we have normal reaction is equal to mg. So instead of n here, what can we write? We can now write m into g. So from here I can cancel out m, and then what we have is minus mu k into g, which is 10, is equal to a, right? What is the value of a? A we found to be minus 4, Therefore, what is mu k is equal to? Mu k would therefore be equal to, let's cancel out minus and minus, so we have 4 by 10, which is equal to 0.4. So the correct option here would be, the value of friction is 0.4. As shown in the figure, a block of mass 10 kg lying on a horizontal surface is pulled by a force acting at angle 30 degree, mu as being 0.25. Just start to move for the value. The block will just start to move for the value. Okay. See, this question, I would take this as an opportunity to discuss further on static friction and kinetic friction. So those who want to have the direct answer, you have it over here. right? So basically what I've done is I've visualized the situation, I've drawn the free body diagram, dissolved the forces into horizontal and the vertical ones, given the logic for the resolution here. So basically this becomes from this triangle you can resolve a vector f into two components, one horizontal and the other vertical, horizontal force and the vertical force, and you can find out the component using this triangle ABC, where sine theta will be equal to BC by AC and cos theta will be equal to AB by AC, and you have the formula. So what is BC? BC will be equal to F sine theta, and what will be AB? AB will be equal to F cos theta. Then you can apply sigma Fy is equal to 0 and then sigma Fx equal to MA, and then you have the answer. Okay. So, yeah, those who don't want to go for the in-depth explanation of static friction, you have the answer here. This is it. The complete values is being derived here. However, if you want to understand static friction in a bit more detail, which I suggest you should do, because that will really help you in developing your concepts. So I'll say the definition of limiting friction, and then we'll go into see what is static friction. Okay. So what is limiting friction? It is defined as the maximum frictional force. Mind you, it's the maximum frictional force that needs to be overcome to initiate motion. It acts when a body is just about to move or slide across the surface of another body, just about to move, okay? And directly proportional to the normal reaction. So what is this we're talking about? We're talking about limiting friction. So the key points that we need to understand here is that limiting friction is actually the maximum friction value, okay? And it comes into picture when the object is just about to move. Okay, now let me take you through an example where there is an object of 1 kilogram mass. F external is acting towards the right, and we know that static friction will oppose the motion, right? And we have normal reaction and mg. So since the object is restricted along the x-axis, along the y-axis there is no motion, so we can write that sigma Fy is equal to 0. Now you may ask me how. See, since there is no motion along the y-axis, I can say that displacement along y-axis is 0. Therefore, velocity along y-axis is 0. Therefore, acceleration along y-axis is 0. And therefore, m into ay will be equal to 0, which implies Fy, which is m into ay, is equal to 0. Therefore, sum of all the forces acting in the y direction, sigma Fy, will also be equal to 0. Now, what does it mean when we say sigma Fy is equal to 0? It means that forces acting along the up direction will be equal to forces acting along the down direction. Now, which are the forces acting along the up direction? There's only one, which is normal reaction. So we have normal reaction. Forces acting in the down direction, there's only one force acting on the down direction, which is mg. So we have N is equal to mg. Now, by laws of friction, what do we have the value of static friction as is equal to mu s into n? Assuming that the mu s value is 0.1, we have static friction is equal to 0.1 into m into g. And therefore, static friction is equal to 0.1 into m is 1 kilogram into g is 10. So 10 is in 100, 100 to 0.1 is 10 Newton. Now, this is where most of the students make a mistake. Why? This is not actually static friction. Then what is it? What we have here is the maximum value of static friction. What we have here is the maximum value of static friction. What we have here is the maximum value of static friction. Now, is that word familiar? Exactly. When we say the maximum frictional value, this expression is actually what we found it as the limiting friction. So what is the value of limiting friction? The limiting friction value here is 10 Newton. All right. So when we say mu s into n, we are not talking about static friction. Instead, we are talking about maximum value of static friction, which is actually the limiting friction. And therefore, the value of limiting friction here is equal to 10 Newton. All right. Okay. See, now, once the body has started moving, okay, now I don't want to go much on kinetic friction here. We will reserve that discussion to a separate section. Okay. All I want to tell you is generally, static friction, the value is higher, and kinetic friction, the value is lower. So static friction value is greater than kinetic friction. Why? It is very hard to, let us say, if you just assume this block to be a car, okay, block to be a car. It is hard to push a car from rest, but it is hard to push a car from rest. But once it has it has gained some motion, it has gained some velocity, it is easy to push the car, right? And therefore, the kinetic friction will be less while it is moving, and static friction will be more as it is at rest. We will definitely go through the kinetic friction in detail, but not in this question. So let us come back to our the concept that we were interested in. So I hope you have understood about. Oops, my bad. The value of limiting friction, right? Now, if you understood the value of limiting friction, let us take some time to understand the concept of static friction here. So we have the same example. There is F external acting here, and there is static friction opposing it. Now this time I mean static friction and not the maximum value of static friction. So what are we trying to do here? We're trying to understand the significance of F external. We're talking about the significance of the net force and not the static friction. Okay, why? Because F net is actually dependent on both F external and the static friction. Let's see how. So this might be a little bit confusing. Maybe you'll have to go through the explanation a couple of times and write it down on your own and explain it to yourself to get a better picture on it. Anyway, I'll try my best here. So there is a body of 1 kilogram mass, right? How many forces are acting along it? As we said, sigma Fy is equal to 0. So I'm not going to consider about the normal reaction and the weight here. We'll be discussing only about F external and static friction. Okay. So static friction will oppose the motion. F external will try to induce the motion, right? Maybe I'll just write it over here. Static friction will oppose the motion, whereas F external will induce the motion. So what is the value of static friction? That's what the point of discussion here. So I can write here that F net is actually the difference of F external and static friction, right? F net is the difference of F external and static friction. The signs is something that we can discuss later. Let me just say this is the difference of F external and static friction. Okay. Now please pay your maximum attention here. When the F external is 0, which means when there is no force acting on this body here. Okay, when there is no force acting on this body, the body is at rest, right? Therefore, static friction also at rest. Now, from the previous discussion, we have here that the value of static friction. Oh my bad. So the value of limiting friction here is 10 Newton, right? The value of limiting friction is 10 Newton. So I'll make use of that reference here. The maximum value of static friction is 10 Newton, right? Or otherwise, friction limiting is equal to 10 Newton. Okay. So in the first case, what's the value of static friction? Okay, maybe you will understand better when I write down things along with this. Now you may say that the maximum value of static friction is 10 and therefore the value here should be 10. No, the value here is 0. And what is F net? The difference between F external and SF, which is 0 minus 0, 0. Okay. Now let's see, if I increase the value of F external to 2 newtons, what will be the static friction now? What is the maximum value of static friction? The maximum value of static friction is 10. So you will always check this condition. What is the value of F external? And then you'll compare that with limiting friction. If the value of F external is less than limiting friction, then the value of F external will be that of the static friction. Okay, let's see that one more time. F external, if that value is less than limiting friction, then the value of static friction will actually be the value of the F external. We have doubt? We'll make it clear. What is the applied external force here? 2 Newton. So 2 Newton is less than 10 Newton, right? Therefore, what will be the value of static friction? It will be equal to F external, which in this case is 2 newtons, right? Which in this case is 2 newton. Therefore, what is F net? F net is difference between F external and F static friction. 2 minus 2 is 0, right? Okay. You have doubt? We'll take a couple of more examples. Let us increase the value of F external to 4 newton. Now, if the value of F external is 4 newton, substitute it over here. F external is 4. What is the maximum limit? It is 10. 4 is less than 10, right? 4 is less than 10, and since 4 is less than 10, we can say that static friction in the value is equal to F external, and therefore the value of F static friction here would be 4 newton, and we can say that F net will again be 4 minus 4, which is equal to 0, right? Now, if F net is equal to 0, what does it mean? It means that the velocity acceleration of the body is 0, which means the velocity of the body is either constant or it is 0, right? So the body may, in this condition, the body may tend to be in rest. Let us increase the F external. Now this is 6 newton. 6 again is less than 10. And since 6 is less than 10, we can say that static friction will be equal to the F external, and therefore here as well we have the value of static friction to be 6 newton. Therefore F net will be difference of these two, 6 minus 6 equal to 0. 8 newton, again you'll get the static friction to be 8, and therefore the net force will be equal to 0. Now, when static friction is equal to the maximum value, we say when the static friction is equal to the maximum value, then although the net force here is 0, the body will tend to move. Why so? See, that is what we were discussing the very first term here. The body is just about to move or slide. The body is just about to move or slide when the maximum value of frictional force is attained. So what is the maximum value of frictional force here? The maximum value of frictional force here is 10 newton, and therefore in this condition the body will tend to move. What happens prior to that? During all these conditions, the body will be at rest. Now let's try to understand what happens after this. Now, if the F external is 12 newton, the condition here reverses. What does it become? It becomes F external is greater than limiting friction, and when F external is greater than limiting friction, this condition is readily violated, right? And what happens to the static friction now? The static friction now becomes what? Can you make a guess? The static friction now becomes 0. But what happens to the F net? F net remains the same. Why? Because F net is the difference between these two. So 12 minus 0, now what we get is, we get acceleration here, right? What we get is 12 minus 0 as 12. No. Why? Because we also have something called as kinetic friction. Say in this case, for example, is 9 newton. Now, since the body is moving after this condition, the body has started to move. So rest tends to move, and then it moves. When it starts to move, which friction will come into picture? Kinetic friction will come into picture. And when kinetic friction comes into picture, we will have to include that value here. So this time the net value will be F external minus, instead of static friction, we have kinetic friction, and therefore 12 minus 9, what we get is some value 3. Okay. Now, kinetic friction remains constant. Why? Because it is not a self-adjusting force, whereas static friction is a self-adjusting force, and that is why you see the value being adjusted like this. Okay. Now, next case, kinetic friction remains 9. 14 minus 9 you get as 5 newton, and therefore there is some F net, and therefore definitely there will be an acceleration. The body is in motion. Static friction again remains 0, but kinetic friction takes up, and once kinetic friction is overcome by F external, there will be motion in the body. Okay, which otherwise means that all these values here, as you said, will have to be how much? Yep, it has to be 0 because the object was in rest, and therefore during the condition when the object was in rest, kinetic friction value will be 0. And when the object is in motion, the kinetic friction will come into picture, but the static friction would be 0. Okay, so that's the point here. That's the concept here. So let me just summarize these things. So block will tend to move when F external is equal to maximum value of, not SF, will be the maximum value of static friction, or in other words, which is equal to the limiting friction. Block will move freely when F external is greater than kinetic friction. Block will be at rest when static friction is greater than F external. Okay, so that's the concept behind static friction. Now let us come back to the question here. So what does the question say? The question says that the body is just start to move. In which case, which friction do we have here? Is it static friction or kinetic friction? It is definitely not static friction, kinetic friction. It has to be static friction. Now the force is applied at an angle 30 degree. So let us first resolve the force, right? Let us first resolve the force. How do we resolve the force? We will resolve the force to go in two directions. One would be the horizontal direction like this. The other would be the vertical direction like this. And then you can replace this vector from here, right? You can replace this vector from here and keep it over here, right? And therefore what essentially we get here is we can draw this as a triangle with one vector like this and the other vector like this, horizontal and the vertical components. And if you complete this triangle ABC, what is sine theta from here? Sine theta will be opposite, which is BC, by adjacent, which is by hypotenuse, which is AC, and the magnitude of hypotenuse is AC is F. Therefore, what is BC? BC will be AC sine theta. BC is AC sine theta. AC is F. Therefore, BC equal to F sine theta. Similarly, we can write that AB is F cos theta. Right? The value of theta is 30 degree. Okay. After that, we come back to the free body diagram. When we have the free body diagram, how many horizontal forces are acting here? Static friction is acting towards left. The F external is acting in horizontal and vertical direction. We found out to be F cos theta and F sin theta. Vertically, we have mg and n. Now, since Fy is equal to 0, we can write that sum of, okay, what does Fy is equal to 0 imply? It implies that forces, sum of forces acting in the up direction will be equal to sum of forces acting in the down direction. So along the positive y axis, right, along the, or say the north facing forces, we have direction, we have two forces. One is normal reaction and F sine 30. So sigma Ff means we'll have to add these two. So we have F sine 30 plus 9 is equal to sum of forces in down direction. There is only one force which is acting in down direction, which is mg. So we have F sine 30 plus n is equal to mg. All right. Now, most of the students assume here that the body is in equilibrium, and therefore SF is equal to F cos 30. No. It is not the case. The case here is, since the body is just start moving, what can we say? The value of static friction here would be the limiting friction, which actually will be equal to the F external. And what is F external? It is F cos 30. What is the value of static friction? The maximum, sorry, my bad. This here should be the value of maximum static friction. What is the value of maximum static friction? Maximum static friction value is mu s into n. But what is n from here? N from this equation would be mg minus F sine 30, right? So instead of n here, I can write mu s into mg minus F sine 30 is equal to F into what is cos 30? It is root 3 by 2. Now, so we have mu s. What is the value of mu s? It is 0.25. My bad. The value of mu s is 0.25 into m is 10, g is 10, F sine 30. Sine 30 is 1 by 2. Algebraic manipulations. So 25, 0.25, let it as 25 by 100, right? Minus 10 into 10 is 100. So I'll let it as 2 into 100, 200 minus f by 2. So 25 by 100 is 1 by 4. 2 into 100 is 200 minus f by 2 is equal to cos 30 is root 3 by 2, root 3 by 2 into f, right? And further, I'll write 200 minus f is equal to, now see, 4 into 2 is 8, right? That by 2 is 4. Or maybe let me just simplify this. So 2 by 2 is 1, and then you can transpose this 4 to the RHS. So 4 will go to the RHS. What we have, 200 minus f is equal to 4 root 3 into f. 200 is equal to negative f to the RHS will give you 4 root 3 f plus f, right? If you take f common, what we have is 4 root 3 plus 1. So 200 is equal to 4 root 3 plus 1 into f. Therefore, what is f? F is therefore equal to 200 by 4 root 3 plus 1. Now, how would you simplify this? See, now we can directly go into the options and eliminate if you want to, but I would say to be on the safer side, just spend a couple of more time, maybe not a couple of seconds, maybe 10 or 20 seconds more. What's the value of root 3? Yes, somewhere around 1.73. So what is 1.73 into 4? You have 6.92. What is that plus 1? 7.9, which I can approximate this as 8, right? So basically what do we have? 200 by 8, which is approximately, well, okay, 200 by 8 is definitely not approximate. It's a definite value, it's 25. But since it's approximated, we approximately get this value to be closest as 25 newtons. Okay, so yes, I did take a bit longer than usual, I would say, to explain, because I wanted you to go through the concept of static friction. And see, solving this question is important. Yes, definitely is, because ultimately that's what you wish to do. But what's even more important is to understand the concept behind it, because if you don't understand what does it mean when the question says when the question says bodies just start to move, and if you don't know that when a body is just starting to move, the maximum value of static friction becomes the limiting friction, which actually is equal to the F external, then there's that is the point, that is the concept the question is trying to evaluate on you. So that understanding that becomes really important. All right, so that's it with this question. A block of mass m slides down the plane at an angle 30 degree with acceleration, it's g by 4, my bad, g by 4. The value of coefficient of kinetic friction will be. So the flow chart, as usual, to assume this problem, what would that be? We'll visualize the concept, the question. We will set the frame of reference, identify the system, isolate the body, and then go for sigma fx and sigma fi and find out the unknown. So let's first visualize this. Angle 30 degree, inclination. A block of mass m is sliding down. Okay. Now, when the block of m is sliding down, we know that this weight can be resolved into two components. One is mg sin theta and the other is mg cos theta. You may have a doubt how. Let's quickly go through the resolution also. So we have and slope theta. Weight of this block is acting downwards. I'll take this vector. Weight is acting downwards. Well, essentially it should be acting from the center of this, right? It should be acting from the center of this, but it being a vector, I can displace it, right? So just keep it over this place. So we have the weight vector here. This angle is theta. Weight was acting perpendicularly, so this angle is 90 degree. So in this triangle, let us say triangle DA, triangle DAC, 90 plus theta, this angle will be 90 minus theta. One weight, okay. Now, how are we resolving this? That's also important to understand. We are resolving it into two components. One, which is perpendicular to it. Perpendicular to what? Perpendicular to the inclined surface. And the other, which is parallel to the surface, right? So we have two components. One, which is parallel to the surface. Two, which is perpendicular to the surface. So since this component is perpendicular, we can say that the angle between these two components would be 90 degree, and therefore this angle is 90 degree, right? So we have this angle to be 90 degree. Now look at this complete angle here. This complete angle here, since the vector is perpendicular, this complete angle is 90 degree, right? One portion of this is 90 minus theta, and therefore the other portion should definitely be equal to theta. So in this triangle ABC, we have this angle to be theta. So triangle ABC, we have this angle to be theta. And if this is theta, what is sine theta? Opposite by hypotenuse. What is opposite? BC. Hypotenuse, which is AC. So what is BC is equal to? So sorry, yeah. So what is BC is equal to? BC will be equal to AC into sine theta, right? BC will be equal to AC into sine theta. What is AC? AC is mg. So we have mg sine theta is equal to, what is BC? We can write BC as horizontal component of weight, right? Horizontal component. So what is mgx? Is BC, which is mg sine theta. What is AB? AB from this equation will be AC cos theta, right? So we have AB is equal to, instead of AC, we have mg. So that is mg cos theta. Now what is AB? AB is otherwise the vertical component of weight, mgy. So what is mgy? It is mg cos theta. Now coming to the given question here. The vertical component is mg cos theta. The horizontal component is mg sin theta. Okay. So we have visualized. We have set the frame of reference. I will choose it to be inertial frame of reference. Okay. And now let us find out the system. We have the system, the overall system here. Let us isolate the body. I have isolated this body here. And then we go for sigma fx and sigma fy. Let us see how. So if you observe in this block, there is one component which is mg sin theta, which is the horizontal component. Vertical component mg cos theta, and since this is in contact with the surface, there will be a normal force, normal reaction acting perpendicular to it. So now let us apply sigma fx is equal to ma and sigma fy is equal to 0. So you may be asking, why is sigma fy is equal to 0? Because there is no motion. Why is sigma fy is equal to 0? Because there is no motion in the y direction. So displacement in the y direction is equal to 0. Therefore velocity in the y direction is equal to 0, and therefore acceleration in the y direction will be equal to 0. And if you multiply this by m into ay would be equal to 0. And what is m into ay? It is fy, and therefore sigma fy will be equal to 0. What does it mean further? It means further that forces acting in the up direction would be equal to forces acting in the down direction. What are the forces acting up? The only force acting here up is normal reaction. So we have n is equal to, what are the forces acting down? The only force acting down here is mg cos theta. So we have n is equal to mg cos theta. However, sigma fx is not equal to 0 and sigma fx is instead equal to ma. Why? Because there is motion only along the horizontal direction. And along the horizontal direction, we have two forces. One, which is mg sin theta, and two, which is mu k into n. Now you might be asking, how do you take this to be positive and the other to be negative? Let's understand the concept as well. So the overall direction of this motion is towards downwards, right? So all those forces which are acting along the net direction of motion, so the net direction of motion is downwards, so all those forces which are acting on the net direction of motion would be taken as positive. All those forces which are acting against the net direction of motion would be taken as negative. Let's do that one more time. So this is the net direction of motion. There is one force acting along it and another force acting against it. So that force would be taken as negative. The acting one along would be taken as positive. And since mg sin theta is acting along the direction of motion, we'll take mg sin theta as exactly as positive. And since kinetic friction is acting opposing or acting against the direction of motion, we'll take that as negative. Now what is kf? Kf is mu k into n, right? What is kf? Kf is right over here. So what is kinetic friction is equal to? It is equal to mu k into n. But what is n? N is equal to mg cos theta. So we have here, instead of n, we can write here mu k into mg cos theta. Now all of this being equal to ma. So now I'll divide this entire equation, right? I'll divide this entire equation by m. So we have m by m, mg by m, and ma by m. So m by m is 1. So what we get is g sin theta minus mu k to g cos theta is equal to m by m is 1 is equal to a. Now what I'll do is, what is acceleration? It is given in the question that acceleration is equal to g by 4. So now we have g in all three terms. So we'll divide this entire equation by g. G by g is 1. So we have g by sin theta as sin theta Mu k g cos theta g by g is 1. So mu k cos theta g by g is 1. So we have 1 by 4. So sin theta, theta is 30 degree here. So sin 30 is 1 by 2. Cos 30 is root 3 by 2 is equal to 1 by 4. And minus mu k into root 3 by 2 is equal to 1 by 4. I'll transpose this 1 by 2. So this becomes minus 1 by 2. So minus mu k into 3 by 2 is equal to 1 by 4 minus 1 by 2. I'll multiply this 1 by 2 by 2 and numerator and denominator. So what we get is mu k into root 3 by 2 is equal to minus 1 minus 2 by 4, which is minus 1 by 4. So minus mu k is equal to 2 into minus 1 by root 3 into 4, which is minus 2 by minus 4 is minus 2. So what we have is minus mu k is equal to minus 1 by 2 root 3, and therefore mu k is equal to 1 by 2 root 3, which gives us the correct answer as 1 by 2 root 3, option B. Time taken by an object to slide down 45 degree rough inclined plane, time taken by rough inclined plane is n times as it takes to slide down a perfectly smooth plane. Time to travel down smooth plane, ts, is n times. So time for rough is n times time for smooth. Okay. The coefficient of kinetic friction between the object and the inclined plane is. It's a very good question. It's a really good question because it's it checks your concepts from not just this chapter but a couple of other chapters. All right, let's discuss case number 1 where it is smooth plane. Now in smooth plane, it is a perfectly smooth plane, which means kinetic friction doesn't exist here, right? So there is an object here, inclined plane 45 degree, coefficient of kinetic friction and static friction is equal to 0. The forces acting on the block are normal reaction acting upwards and weight acting downwards. Now this weight can be resolved into two components. One, the vertical component, which is mgy, and the other, the horizontal component, which is mgx. So weight can be resolved into two components, mgy and mgx. Now we know that when we resolve the forces, what do we get? When we resolve the forces, we can resolve this mg into two components, one which is mg cos theta, which is the vertical component, and then we have mg sin theta, which is the horizontal component. Now the only other force acting here is normal reaction. To be more precise, this is normal reaction on the block due to the inclined surface. One more time. This is normal reaction on the block due to the inclined surface. I mean, not this surface. It is this inclined surface which is providing the normal reaction on the block. Okay. So we have the free body diagram. Now let us use the conditions, which is sigma Fy is equal to 0 and sigma Fx is equal to ma. Now why is sigma Fy is equal to 0? See, the motion is taking place, okay, or otherwise there is no motion along the y-axis. What does that mean? If there is no motion along the y-axis, it means that object will keep following only this mg sin theta direction. It will go only in this direction. It is not going upwards or it is not going downwards. It is restricted to the, it is restricted to the x-axis, not to the y-axis. So since there is no motion along the y-axis, we can say that displacement along y-axis is equal to 0. What does that imply? It implies that velocity along y direction is equal to 0. Further, acceleration along y direction is equal to 0. And if we multiply m on both sides, what we get is m into ay is equal to 0. And what is m into ay? It is Fy is equal to 0. So we can say that sigma Fy is equal to 0, which implies that forces acting upwards should be equal to forces acting downwards. Now what are the various forces acting upwards? The only force acting upwards is normal reaction on the block, which is equal to forces acting downwards is mg cos theta. So we have n is equal to mg mg cos theta, right? Okay. Now, what is sigma fx is equal to ma implies? Sigma fx is equal to ma implies that all the force acting in the x direction, sum of all the force acting in the x direction is equal to ma. What are the various forces acting in the x direction? There's only one force, which is mg sine theta. Now you may be wondering, what sign should I take? Should I take positive or should I take negative? See, for that, what is the overall direction of motion? It is downwards, right? What is the direction of mg sine theta? It is also downwards, right? So, since both of them are in the same direction, we will take mg sine theta to be the positive one. So, this is basically plus mg sine theta is equal to ma. And if you cancel on both sides, what we have is acceleration is equal to g sine theta. Now, we already have discussed this as a standard result, that the acceleration on a smooth plane is equal to g sine theta. But however, since we are going through questions, it is good to revise these concepts, and things become as a it should become a perfect memory by practice. It's not that you memorize things; it should come by practice, right? Okay. So now let us go through. Okay, I don't want to go through the smooth plane. Let us now visualize the second part. So what is the second part? The second part is that the object is the same and the block is sliding down, but what's different here? That the inclined surface here is not perfectly smooth. There is some amount of kinetic friction. Alright. Now what are the various forces acting on the body? Since there is kinetic friction involved here, we can definitely say that kinetic friction will oppose the motion, right? The object is sliding downwards. Therefore kinetic friction will be opposing it upwards. There will be normal reaction acting on the block. Again, there will be normal reaction acting on the block due to the inclined surface, right? And then weight of the block acting downwards. Now, when we have weight of the block acting downwards, we know that it can be resolved into two components. One, the vertical component, and two, the horizontal component, right? So the horizontal component here would be mg sine theta, and the vertical component here would be mg cos theta. So we have the free body diagram of the block. Now let us apply the same conditions as we took earlier, which is sigma fy is equal to 0. Why? Because block is sliding along the plane which is only along the x-axis, and there is no motion in the vertical direction, which is the y-axis. And since there is no motion along the y-axis, we can say that vy is equal to 0, and further implies that ay is equal to 0, and therefore m into ay is equal to 0, which implies fy is equal to 0, right? And since sigma fy is equal to 0, we can further say that all the forces acting in the up direction, right? All the forces acting upwards should be equal to all the forces acting downwards. What are the various forces acting upwards? The only force that is acting upwards here is the normal reaction. So we have normal reaction n is equal to what is force acting downwards? The only force acting downwards here is mg cos theta. So this is equal to mg cos theta, right? Some of you may have a doubt here. Isn't that mg sin theta is also acting downwards? No. Why? Because mg sin theta is the horizontal component of weight, whereas mg cos theta is the vertical component of the weight. So that's what we say. So maybe we should stick on to using vertical component. So the vertical component n along upwards, vertical component mg cos theta acting in the y direction, maybe positive y or negative y. Okay, right. But as in the previous case, we can say that sigma fx is equal to ma, unlike sigma fy equal to 0. Now when sigma fx is equal to ma here, what are the various forces acting here? Now here we may have to spend, maybe I just make use of one more diagram so that things become clear to you. So say the net direction of motion is along the plane, right? kinetic friction is acting against it, mg sine theta is acting along it, right? So we have mg sine theta, along it, whereas kinetic friction is against it. So against the net direction of motion, we will take it to be negative. Along the net direction of motion, we take it to be positive, and therefore we'll write it as plus mg sine theta minus kf, plus mg sine theta minus kf, plus mg sine theta minus kf, plus mg sine theta minus, plus mg sine theta minus. And what is kf? Kinetic friction is coefficient of kinetic friction times the normal reaction. And what is the normal reaction? We just found out the normal reaction to be equal to mg cos theta. So instead of normal reaction here, we can write here that this is equal to mg cos theta. And since normal reaction is mg cos theta, all these three terms now have m with them. And what can I further do? I can divide this entire equation by m. And what do I get? G sine theta minus mu k g cos theta is equal to a. Now I've written AR. What does R imply here? It means acceleration along the rough plane, as opposed to the first one, which was acceleration along the smooth plane. Now you might be wondering that we are asked to find out the, what were we asked to find out? We were asked to find out the kinetic friction, but we only have the acceleration rough and acceleration smooth here. Now how do we derive it? The answer. For that, what we'll do is we will make use of the equations of motion. Now let's have a look here. So I have taken displacement time relationship. I have made use of the displacement time relationship, which is otherwise called ST time relationship, which is S equal to UT plus half AT square. Now I'll replace S with SR, U with UR, and T with TR. I hope the concept remains clear to you. Why? Because SR is displacement along the rough plane. UR is initial velocity when the object was kept in the rough plane. What is TR? Time taken for the travel along the inclined plane when the plane was rough. Simple? Right. So now we have SR is equal to, since it is from rest, UR is equal to 0. So that term is completely eliminated. So we have displacement along the rough plane is equal to, okay, wait, is equal to, this term is, okay, is equal to half into acceleration along rough into TR square, right? Now, what is acceleration along the rough plane? Let's see. Acceleration along the rough plane is from here is equal to, maybe I can just copy down it over here. So acceleration on the rough plane is this value, right? So we have acceleration along the rough plane as SR is equal to half into G sin theta minus mu k into G cos theta into TR square. Now, similarly, we'll have to find out the case 1 where the acceleration is along the smooth plane. Everything remains the same except that we replace R by S. Initial velocity is 0, that is eliminated, and A here is G sin theta. So we get is SS is equal to, displacement of smooth direction is equal to half into G sin theta TS square. Now what we'll do is we'll bring these two equations together, and then we'll try to understand what does it mean. I'll write it one more time, right, for better clarity here. So mu k is unknown in both cases. Sorry, in the second case, because it is rough, and this case it is smooth. Now in both the cases, the block is the same, the inclined plane is the same, which means this distance d is the same. This inclined distance d is the same. Therefore, we can say that SR, displacement along the rough, should be equal to displacement along the smooth, should be equal to d, or both of them can be equated, right? And we just found out these two equations, displacement time relationship. But it is given that SR is equal to S is equal to S, or D being the same plane, right? which means these two equations can now be equated. And now if I equate these two equations, what do we get? What we get is half into g sine theta minus mu k g cos theta tr square is equal to half into g sine theta ts square. So the first step will be to we will remove half from both sides. Now what do we have? G sine theta minus mu k g cos theta tr square is equal to g sine theta and ts square, right? Okay. Now every term has g, so I'll divide this complete equation by g. I'll divide this equation by g. So g is eliminated from the set of equations. Now what we have here is sine theta minus mu k cos theta tr square is equal to sine theta into ts square. But it is okay. Now what's the value of theta? Theta is 45, so it is sine 45. Cos theta is cos 45. Sine theta is sine 45. Now, since it is 45, we know that if theta is equal to 45, sine theta is equal to cos theta, right? So instead of cos 45, I can write sine 45 here. And after writing the same equation, I'll divide this complete equation by sine 45. Now sine 45 by sine 45 is 1. Sine 45 by sine 45 is again 1. Sine 45 by sine 45 is 1. So what we have is 1 minus mu k into tr square is equal to t square. But what else do we have from the question? The question also says that tr square is n times t square, something that we discussed the very first part of the question, right? So tr square is n times t square. So we can write that 1 minus mu k into tr square can be replaced with n into ts the whole square. Now n into ts the whole square means n square ts square. Now we have ts square on both sides. So what can we do? If we divide this, so we can cancel out these two terms, right? Now what we have is 1 minus mu k into n square is equal to 1. Now this gives us 1 minus mu k is equal to 1 by n square. So if you transpose 1 by n square to the LHS, what we get is 1 minus 1 by n square is equal to mu k. And if you check the final answer, what we get is 1 minus 1 by n square. Consider a block kept on a inclined plane, 45 degree. Force required to just push it up is 2 times the force required to just prevent it from sliding down. See, as we discussed in the previous problem, which word is important here? Exactly. Just prevent it from, just push it up. Why? Because we know that if the block is just moving, then the value of the frictional force would be equal to the limiting friction, or otherwise the maximum value of static friction or the maximum limit of static friction, and is numerically equal to the product of coefficient of static friction times the normal reaction, right? Okay. Now, if the body is at rest, it means that the value of friction is equal to the applied external force. If the body is in motion, the friction force is less than that of the F external force, and there is a significant difference between F external minus F of friction, which actually gives the body some acceleration, right? Of course, this friction is now kinetic friction and not static friction. So yes, we do have this kind of understanding about this, the basic concept of friction. Now let's see what's given in the question. So the question says that the body has to be pushed up, case number 1, and case number 2, the body has to be prevented from coming down. See, in both these cases, if we have to make this block go up, you will have to apply an F external in this direction, right? Now, if the block is sliding downwards and you want to prevent that sliding downwards motion, what should be the direction? It should be applied upwards. So, in both these cases, so-called F external in both these cases is along the same direction. It is against the incline of the plane, right? So in order to distinguish between these two F external, what we'll do is we'll choose the terminology as F up and F down. All right. And according to the question, it is 2 times the force required just prevent it from sliding down. So F up is equal to 2 times F down. All right. So this is what we have. Now let us take these cases individually, starting with case 1. So in case 1, if we visualize the concept, if we visualize the given condition, slope of inclination is 45 degree, the force is sliding. Let me make use of the diagram. The movement of the block here is upwards like this, right? The block is moving upwards. Now, if the block is moving upwards, what do you think is the direction of friction? Exactly. Direction of friction should be friction should be the other way around, which comes like this, right? So this is how friction should act. All right. So if this is the force which vector which represents friction, let me draw it over here and represent as static friction. Why static friction? Could it be kinetic? No, because the body is just moving up. So the friction is still static friction. Now let us see the various forces acting on the block. Primary force is the force of gravitation, which results in m into g. So weight acting downwards. Second is normal reaction, which is acting perpendicular to the surface. Which surface? The surface here is the inclined plane, right? So normal reaction acting perpendicular. And then we have the static friction, which is acting downwards. Now the primary force of interest here, which is force upwards. All right. Now let us see the free body diagram. So in the free body diagram, we know that weight which is acting downwards can be resolved into two components. One component which is parallel to the inclined plane, another component which is perpendicular to the inclined plane. One more time, weight can be resolved into two components. Number one, the parallel component which is parallel to the inclined plane, the vertical component which is perpendicular to the inclined plane. The rest forces remain the same, which is N, static friction, and force up. All right. Now let us apply the condition. So what conditions do we have here? Since this motion is restricted only along the horizontal, since there is no motion along the vertical axis. What do I mean by that? What I'm trying to say is this block is moving only like this. There is no vertical motion. It is not bouncing up, nor it is penetrating the plane and coming down, right? Therefore, we can say that displacement along the y direction is equal to 0. If displacement along the y direction is 0, we can say that Vy is equal to 0. For Ay is also equal to 0. And if you multiply m into Ay, what do we get? What we get is Fy is equal to 0. And therefore, sigma Fy should also be equal to 0. Now, what does it mean when we say sigma Fy is equal to 0? When we say sigma Fy is equal to 0, it otherwise means that forces acting upwards should be equal to forces acting downwards. Now in this case, please don't get confused with this F up. Okay, we have different. Let me write it full. Yeah, okay. Now what is F upward here? The only force acting upward here is the normal reaction. So we have normal reaction N is equal to the only force acting downwards is mg cos theta. So we can write it over here, mg cos theta. So what is the value of N? N is equal to mg cos theta. Now let us come to the case where we have sigma fx, right? So when we study sigma fx here, we know the case as the body is just moving up, the frictional force should be equal to the static the maximum value of limiting friction. Or in other words, we can just write it here that F forces acting along the right direction should be equal to forces acting along the left direction, right? Now, what are the various forces acting in the right direction? Along the right direction, the only force acting here is F upwards, which is equal to, along the left direction, what we have is static friction and mg sine theta. So this becomes static friction plus mg sine theta. But what did we derive what did we know the value of static friction as? The maximum value of static friction here would be coefficient of static friction times the normal reaction. And what is normal reaction? We derived it to be mg cos theta. So we have F up is equal to mu s into mg cos theta plus mg sine theta. Now, can you do the rest? Well, you should be able to. Let us now have a look at the second case. Visualizing first, horizontal inclined plane 45 degree. The F external acting here is in the same direction, but what makes this case different? Here the body is trying to come downwards, and therefore what will be the direction of friction? The direction of friction will be opposing the motion, right? Now, if you see the various forces acting on the block, the first force is always the force of gravitation, which results in the weight, right? And then we have the force acting downwards and friction opposing it, normal reaction, which is perpendicular to the surface, which is this, in this case, the inclined plane. Now let us draw the free body diagram. So when we draw the free body diagram, we know that weight can be resolved into two components. Horizontal component, which will be parallel to the inclined surface. Vertical component, which will be perpendicular to the inclined surface. Horizontal component here is mg sine theta. Vertical component here is mg cos theta. All right. Net direction of motion is actually not present because the body is just trying to move. However, the body is tending to move downwards. Therefore, static friction would be acting upwards. Okay. And the force applied here is also upwards. Why? Because only then the body will tend to move upwards when it is moving downwards. Okay. Now let us see the cases. So as we did earlier, we know that normal reaction here would be equal to mg cos theta. Now F left should be equal to F right. F right, we have two forces here. Oh, maybe I should. Sorry, my bad. I'll just make a correction here. This is F right is equal to F left. Okay, so F right, in the right direction, how many forces do we have? We have force acting downwards, force to prevent the downward motion, Fd, and then we have static friction, Sf, which is equal to, the only component acting here is mg sine theta is equal to mg sine theta. Now Fd plus, what is the value of static friction here? The value of static friction here is the maximum value of static friction, which is mu s into n. And what is n? N here can be written as, right, so n here can be written as, from this value it can be written as what? It can be written as mg cos theta, right? Now what I've done is, I've taken this value mu s mg cos theta to the RHS, so which essentially means I have written F downwards as mg sine theta minus mu s into n, which is minus mu s into mg sine theta. Okay, right. So now we have got two equations. Let us spend some more time to solve these two equations, and things will become clear to you. So we have Fd is equal to mg sine theta minus mu s mg cos theta, and F up is equal to mu s into mg cos theta plus mg sine theta. Now, since theta is equal to 45 degree, we know that sine theta and cos theta, both of them are equal to 1 by 2. Since theta is equal to 45 degree, both of them are equal to 1 by 2. Both of them are equal to 1 by 2. So, in this complete equation, we can make the RHS as a common denominator by root 2. In this complete equation, we can make the common denominator as root 2. Now, it is given to us that f up is equal to 2 times f down, which means this equation is actually 2 times this, which will take us to f up, this equation being 2 times equal to this, root 2 by root 2 is 1. Now we have the numerators being equal. I'll multiply 2 into the brackets, so we have 2 mg minus 2 mu s mg. If I take mg to the, if I transpose mg to the RHS, 2 mg minus mg is mg. If I transpose minus 2 mu s mg to the LHS, what we get is 2 mu s mg plus mu s mg, which is equal to 3 mu s mg. M by m is 1, g by g is 1. So essentially what we get is 3 mu s is equal to 1, and therefore mu s is equal to 1 by 3. A bag is generally dropped on a conveyor belt moving at a speed of 2 meters per second. The coefficient of friction between conveyor belt and is 0.4. Initially, the bag slips on the belt before it stops due to friction. The distance traveled by the bag on the belt during slipping motion is. Now, see, this is one such question which will evaluate almost every concept that you have learned in this chapter so far. I mean, I would say, it covers laws of motion. It covers laws of motion, and it covers brilliant aspects of friction as well. Also, it is very much linked to relative motion that you study in your second chapter. Okay, so this is a very good question, and these kind of questions also give you an insight on the comparison between inertial frame and non-inertial frames. We'll do this question in two ways. First, we'll do it the inertial way. Second, we'll do it solve the questions in a non-inertial frame of reference. But before going to that, let us dissect the question. So what's given to us? A bag is gently dropped. See, each and every word here that I have written here is of much importance because it can alter the pace of the solution. Let's take them one by one. So we have gently dropped. So what would that mean? How would a question vary if the question would have said suddenly dropped? So to explain that, let me take you through one small explanation here. Okay, what do we call this as? So if the bag is gently dropped, okay, if this bag is gently dropped, what's going to happen here is this bag is slower, it's lowered slowly, and it is kept with the on the belt, and slowly it will start moving along with the belt. Okay, I repeat, if the bag is lowered slowly, it will come into rest, then it will slowly move along the conveyor belt and eventually attain the same velocity as that of the belt. Okay, now what will happen if you drop it suddenly? If you drop it suddenly, this bag will come down like this. It will bounce, settle down, and then move with the velocity. Okay, so let's take this one more time. If you slowly keep a bag on the moving conveyor belt, its initial velocity would be 0, and it will pick up the pace. It will slowly accelerate, and then it will keep on going along with the same velocity as that of the belt. Okay. However, if you drop it suddenly, what will happen? It will fall on the belt, it will bounce maybe a couple of times, and then it will acquire the velocity of the belt. Okay, so this condition would make the problem really complex to solve. Okay, so that's why the question specifically says gently dropped. Okay, so that's that. Now let us try to understand the next set of statements. Coefficient of friction, kinetic or static. Initial, well, it should be very clear to you that the friction here is not static, rather it is kinetic. Why? Because there is a relative motion between. Why? Because there is a relative motion between the bag and the conveyor, right? So therefore, it should be the kinetic friction. Now, initially the bag slips. What does it mean? What does it mean when we say the bag slips? If the bag slips, it means that the relative velocity of A with respect to B is not equal to 0. So, slipping condition means that there is some amount of relative motion, and it is not that relative velocity is equal to 0. It is the case that relative velocity is not equal to 0, and therefore the bag slips. Okay. Now it stops due to friction. See, something which is very interesting here is this is one peculiar example where friction actually results in acceleration of the body. Okay. Usually, what is the case? Yes, we know that friction is a retarding force. But here in this example, we'll come to know that friction is actually resulting in acceleration of the body rather than retarding. But having said that, we also need to say that although it is resulting in acceleration, it will definitely oppose the relative motion. Okay. Now, what does slipping motion implies? Slipping motion implies that there is some amount of relative motion and not absolute motion. What is that point? We think will become more clear to you once we solve the entire question. So, part 1, I would like to solve this question using the inertial frame. So now you may have a doubt, what is inertial, what is non-inertial. See, every concept will become clear to you once you pay your maximum attention and once you solve this question on your own without looking at this solution. Okay, right. See, you can revisit the solution, but don't try to copy down things. Okay, listen to the solution once, then try to figure it on your own. And if you come across any doubt, come back again. Okay, let me now take you to the difference between accelerating and non-accelerating frames. Okay. So what is the frame of reference? Frame of reference in its very simple term is the location, okay, where the observer is present, or in other words, simple words, location of the observer. Now the location of this observer could be two. It can be a stationary location, or it can be a mobile location. Okay, if the observer is standing in a stationary location, then that frame is said to be an inertial frame. Okay, if the observer is present in a mobile location, then that corresponding frame is said to be a non-inertial frame. Inertial frames are otherwise called as non-accelerating frames, and non-inertial frames are otherwise called as accelerating frame. Okay. Now, one simple example to understand this would be a person. Okay, say for example, instead of conveyor belt, try to assume that this is a bus, and you have one person, or maybe somebody is sitting in the bus, and you are observing the person. Okay. So what's happening here? The person is moving like this. The person is moving like this. And we need to understand that in this specific case, it is not just the person, but the person is moving. Say, let us call this as VB. And at the very same time, what else is also moving? The conveyor belt is also moving. So we have velocity of conveyor belt as well. So we can see as a person standing outside the, now where is he standing? That's also important. He is standing somewhere over here on the road, which is the ground, and the ground is stationary. right? So the person is observing the man or the object which is inside the bus, which is moving with some velocity vb, and the bus is also moving with some velocity vc. This case specifically, it is moving with a, so this is the conveyor belt. The conveyor belt is moving like this, and we have velocity of block like this. Okay, so we have one object, which is moving like this. Okay, which is like this, and we have a moving conveyor belt. Now, what is accelerating frame? Accelerating frames means the observer who was standing earlier in the ground is now standing within the moving conveyor belt, and the object moves, and at the very same time this person is also moving when the object is in motion. Okay, so here the velocity that we measure is velocity of the bag, velocity of this bag with respect to the conveyor. Okay, so here the person is observing two different velocities, one that of the bag vb and the other that of the conveyor belt vc. Whereas here the person is observing the bag, but where is he standing? He is standing on the conveyor. Therefore this velocity becomes velocity of the bag with respect to the conveyor. Okay, to be more precise, where is this man standing? He is standing on the ground. What is he observing? The block or the bag. So what is the velocity? It is velocity of the bag with respect to the ground. So this is actually VBG. Where is the man standing? He is standing on the ground. What is he observing? He is observing the conveyor belt. So what is this velocity? It is velocity of the conveyor belt, to be more precise, with respect to the ground, right? With respect to the ground. All right. So I hope these things are clear. Now we will use only the first method in this session to solve this question. Okay, so solution using which frame? Inertial frame. Okay. Okay, so sorry for the delay. So now what we'll do is we'll try to understand the non-accelerating frame, the frame or the inertial frame, right? Or the inertial frame. So what's happening here? A person is standing on the ground, and what is he observing? He's observing two objects, one which is the bag and the other which is the conveyor belt. Okay. Now, what does he measure here? Velocity of bag and velocity of conveyor. To be more precise, velocity of bag with respect to where he is standing ground, velocity of conveyor with respect to where he is standing ground. I hope this much is clear. Okay. Okay, now let us see some points here. So this bag is moving in this direction, right? It is dropped. It slowly comes in contact with the bag. There is some inertia here, and then it will slowly move like this. Okay. Now see, this represents velocity of, this represents direction of motion of the bag. Okay, direction of motion of the bag. And what does this represent? This arrow here represents direction of motion of conveyor. So now things are going to be really conceptual here. Make sure that you give your maximum concentration here. This conveyor is moving towards the right. Am I correct? Yes. I hope there's no doubt in that. The bag is also moving towards the right. Okay. Now, if the conveyor is moving towards the right, tell me what would be the friction which is acting on the conveyor due to the bag? Friction will oppose the relative motion, right? So this force here, this vector here would be, this vector here would be the vector which shows friction acting on the conveyor due to the bag. Now look at the concept here. This friction is not acting on the bag. Instead, this friction is acting on the conveyor belt, which is acting due to the presence of bag. Okay? So, what is the concept now? If we know by Newton's third law of motion, if bag is exerting a friction on conveyor, definitely conveyor should exert some friction on the bag as well, which has to be equal and opposite. So, which can write equal and opposite. So, this is friction on conveyor due to belt, and there should be equal and opposite, which we can write it as friction acting on block due to conveyor. So if we were to represent that, it would look like this. So we have now friction acting on the bag. So this is friction acting on the bag due to the conveyor. Okay, I hope that much point is clear. Now please revisit this. This is really important. This concept is really important. You have to understand you should have clarity in this. Now, if I draw the free body of the bag, what are the various forces acting on the bag? The first force definitely would be the normal reaction on the bag due to the conveyor. The second force would be, would be the weight of the conveyor which is acting downwards. And the net direction, let me just write it down here. So the net direction of motion is towards the right. And the only force acting here is friction, but we know friction is acting in the same direction. So this is friction acting on the block due to the conveyor, right? Now, when we consider free body diagram of the bag, we don't consider forces acting on the conveyor, okay? Now, sigma Fy is equal to 0 and sigma Fx equal to 0. Why? This is because the object is in equilibrium. My bad. It's not 0 here. It should be ma. But sigma Fy is equal to 0. Why? Because there is no net motion in the which direction? In the y direction. So what does sigma Fy is equal to 0 implies? As we say, it implies F up is equal to F down, which means forces acting in the up direction should be equal to forces acting downwards. The only force acting here upwards is NBC. So we can write normal reaction is equal to only force acting downwards is mg. So this is N is equal to mg, right? Okay. Now, what is sigma Fx is equal to ma implies? A implies acceleration in the x direction. We will take it as ax. But there is no ay. So if you keep the logic here, is actually a net is equal to root of ax square plus ay square. Since there is no motion in the y direction, what is 0? Ay is equal to 0, and therefore a net will be equal to root of ax squared will be equal to ax. Okay, so I can essentially replace this ax as a. Now let's see the forces. The direction of friction, this is the direction of motion. So since friction is acting along the direction of motion, we will take that as positive, and therefore friction here is acting positive, which means friction is now causing the acceleration instead of retardation, right? Okay, so we have plus mu k into n is equal to mg. Now what is n? N from this equation is equal to mg. So mu k into mg is equal to m into ax. M by m is 1. So we have mu k into g is equal to a. So a is equal to mu kg is what we have. Now let us see this condition here. So here, if we analyze the motion of the bag, it started from rest. This is where the first animation, not the animation, the illustration should come into picture. initially when the bag was kept on the conveyor, its velocity is 0. And slowly it will attain the same velocity as that of the conveyor, which is moving at 2 meter per second. Therefore, the velocity of the bag at the final stage will be 2 meter per second. Right? Why? 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 Very good. See, these kind of questions make you think, because the distance, okay, belt, it stops due to friction, right? Initially the bag slips on the belt before it stops due to friction, so it does stops due to friction. Now when it stops due to friction, when it is moving within a conveyor belt, what can we say about the velocity? Sorry for the lag here. So when it is moving, when it is stopping on the belt, it means that the bag has acquired the same velocity as that of the conveyor belt, which is 2 meter per second. So it essentially means that the relative motion is now stopped. It has stopped due to friction, right? It has stopped due to friction. Now when it has stopped due to friction, friction opposes the relative motion. Or in other words, what is the duty of friction? Duty of friction is to make the relative velocity equal to 0, and therefore velocity of block with respect to conveyor in the final stage will be equal to 0. And therefore we can say that VBC is equal to 0. What is VBC? VB minus VC equal to 0. What does that imply? Velocity of belt is equal to velocity of conveyor, and therefore velocity of belt bag is 2 meter per second. Okay. So initial velocity is 0, final velocity is 2, and we have Ax is equal to G into mu k. Now what? Now we know by Newton's equations of motion that final velocity square minus initial velocity square is 2as, v is 2, initial velocity is 0, 2 minus 0 square is equal to 2 into acceleration is mu k into g, and s is into s. Now why mu k? Of course, because there is some relative motion here. The friction has to be kinetic in nature. 2 square minus 2 square is 4, 4 minus 0 is 4. Mu k is given to us as 0.4, g is 10. So this becomes 2 into 0.4, which is, okay, how did I do this? 0.4 into 10 is 4. 4 by 4 is 1. 1 by 2 is, my bad, it is not 0.2. It should be 0.5. Therefore, the relative distance moved here is 0.5. Okay. Now what we'll see is, so far we discussed the non-accelerating frame, and this time we'll see the case where the observer is also standing on the conveyor belt, but I think I'll do it as a separate one. We'll try to solve the question by looking at the non-accelerating frame. So this was the non-accelerating frame, but the person was on the ground. Now we have the accelerating frame where the person is on the conveyor belt, and the bag as well, both of them are moving together on the conveyor belt. So when you see things from a non-accelerating frame, what this person is observing is the velocity of the bag, which is actually the absolute velocity, or which is practically the velocity of bag with respect to ground, which is velocity of bag minus velocity of ground, but velocity of ground is 0. Why? Because he's on earth, right? So if this is the ground, velocity of ground is 0, and then if you have VB minus 0, which is VB alone, and therefore the term absolute velocity. Or in other words, velocity of bag with respect to the ground is actually velocity of bag, my bad, is actually velocity of bag as seen directly by the observer on the ground. Whereas when the observer is on the moving conveyor belt, and when he is observing a bag which is also moving on the conveyor belt, now what he sees is velocity of bag, okay, where is the man standing? On the conveyor belt. Therefore what he sees is velocity of bag with respect to the conveyor belt, or velocity of bag with respect to conveyor belt, which can be written as velocity of bag minus velocity of conveyor belt. Okay, or to be, let me just write it down one more time. This represents velocity of bag as seen by man on the conveyor. Okay, right. Now, see, this portion here is very important to understand the inertial frame of the study here. Why? What I've done here, I have analyzed the relative motion of bag with respect to conveyor. So, what does it mean? It means that motion of a moving bag with velocity Vb, to be more precise, with respect to ground, on a moving escalator with velocity Vc with respect to ground, and now we know that this ground is not required, right? Absolute velocity can be expressed as motion of a bag with velocity of bag with respect to conveyor belt on a stationary conveyor. Now look at the changes here. We have two components here, one which is velocity of bag and the other which is velocity of the conveyor belt. Now while we study the relative motion, these two parameters got merged into one, velocity of bag with respect to container, and the escalator which was moving is now considered to be stationary. So velocity of A with respect to B actually implies that it is the velocity of A when you compare C at rest or when you observe it from a platform at C. Okay, so here we have an observer who is observing bag and the conveyor. Both of them are traveling at velocity Vb and Vc. Now when you study this in relative motion, motion of a moving bag with velocity Vb on a moving escalator velocity Vc can be expressed as motion of a bag with velocity B with respect to conveyor on a stationary conveyor. Okay, now the conveyor is not moving. So this element, this vector is missing here. Instead, both of these vectors are compressed as velocity of bag with respect to conveyor. I would repeat it one more time. Velocity of bag and velocity of conveyor. So this method has two components of velocity. Now we have or maybe moving bag and a moving escalator is now put as bag with respect to conveyor on a stationary conveyor. Okay, so this is the difference. So that's why we say relative velocity makes the calculation easier. Why? Because here you have Vb, therefore we have AB, we have Vc, therefore you have AC, and therefore SB corresponding SC, right? So you will have three equations of motion here for Vb and Vc. So 3 plus 3 total 6 equations. So the calculation becomes really complex. Whereas here all you need is one equation by replacing velocity with relative velocity of bag with respect to conveyor. So solving one system using 6 equations versus solving one system using just one equation. That's the difference when it comes to using the concept of relative velocity. Now let's see what happens in this case very specifically with respect to relative velocity. See, when we say we have a relative motion under consideration, the conveyor belt is stationary, which is assumed to be stationary, not actually, which is not stationary. It is apparently stationary. Why? Because the man is also standing on the conveyor. Now the bag is moving with what velocity? It is moving with velocity of bag with respect to conveyor. One more time. What is the bag? What is the velocity of the bag here? The velocity of bag is velocity of bag with respect to conveyor. Now, when this bag is dropped, so initial condition represents when the bag is dropped, and final condition represents when it is apparently at rest. So initial condition when the bag is dropped, velocity of bag with respect to conveyor means velocity of bag with respect to velocity of bag initial minus velocity of conveyor initial. Now what is the velocity of bag initial? We know it is 0. Why? Because it has been, let me just make a note of that here as well. It has been gently placed, right? It has been Gently placed. And when it is gently placed, the velocity is 0, but velocity of conveyor with initial is 2. Why? Because the conveyor is moving here with a constant velocity 2 meter per second. Therefore, velocity of bag convey with respect to conveyor initial would be 0 minus 2 negative 2 meter per second. What does it imply? This implies that the observer who is on the conveyor will feel that the bag is coming towards him with velocity 2 meter per second, because velocity is in the negative direction. So he will feel that the bag is coming near to him with a velocity of 2 meter per second. Okay. Well, that's the primary concept that you will be able to understand here. Now, looking at the final condition. What is the final condition? Velocity of bag with respect to conveyor final will be equal to velocity of bag final minus velocity of conveyor belt final. Velocity of bag final is 2 meter per second, and velocity of conveyor belt final will also be 2 meter per second. Why? Because it is moving with 2 meter per second constant velocity, and therefore 2 minus 2 is equal to 0. Therefore, velocity of bag conveyor is 0. What does this mean? It means that observer will now feel that the moving bag has now stopped moving, and that is it has come to rest apparently. Okay, right. So what did we discuss so far? Motion of a bag with relative velocity of bag with respect to conveyor on a stationary conveyor. Okay, now what we'll do is we'll apply the equations of motion in this condition. So we have v square minus u square is equal to 2as. What is v square? vbc. Well, I think I made a mistake here. This is final minus, my bad, this is vbc final minus vbc initial. What is vbc final? We just derived it to be, we found it out to be vbc initial is, sorry, vbc final is 0, vbc initial is minus 2. So 0 minus, this is one place where I see most of the students making a mistake. You know, I would say a really common mistake, because minus 2 square is 4 and 4 into minus is minus 4. Okay, now not plus 4 here, this is minus 4. So minus 4 is equal to 2 into, since you're using relative motion, every other parameter should be in the relative form, which means acceleration here is also acceleration of block with bag with respect to conveyor, and so is displacement, which is displacement of bag with respect to conveyor. So we have acceleration of block with respect to conveyor and displacement of bag with respect to conveyor. But since this is relative acceleration, in a non-inertial frame, you just can't say that acceleration of block with respect to conveyor is acceleration of block or bag minus acceleration of conveyor. Why? Because this is non-inertial frame, and what comes into picture in a non-inertial frame? The concept of pseudo forces, right? So if we were to understand the concept of non-inertial frame, let us first go through a basic introduction of what is non-inertial frame. While calculating forces in a non-inertial frame, pseudo forces need to be considered, which is meant to be acting on the isolated body whose free body diagram is represented, which means our system here, right? Our system here consists of two bodies, one which is the bag and the other which is the conveyor. And since we are interested in the motion of the bag, while considering the free body diagram of this bag, we will also have to include the pseudo force acting on the bag, whose magnitude is given by negative of mass of the body whose free body diagram is considered into acceleration of the frame. And what is the frame here? The frame in this case is the portion where the man is standing, and the man is standing on the conveyor. Therefore, the conveyor is considered to be the frame, and pseudo force will be calculated using the acceleration of this frame and not the acceleration of the bag. Okay. So if you consider inertial frame and the free body diagram of the bag in the inertial frame, there are only three forces acting on it. Number one, which is the normal reaction. Two, which is the weight of the body acting downwards. And then you have kinetic friction acting towards the right. But when you consider the free body diagram of a bag in the non-inertial frame, you have one, normal reaction, two, corresponding to this, which is weight of the body, three, the kinetic friction acting here as well. But as we discussed in non-inertial frame, we also need to add the pseudo force, and this pseudo force here will be represented as force pseudo or F pseudo, whose magnitude is given by mb into AC, which means mass of the free body diagram, mass of the body which is selected for the free body diagram, which in this case is bag. So this is mass of the bag into acceleration of the frame, which is acceleration of the conveyor. And I have taken, since I have represented this as vector, I have taken only the magnitude, otherwise this would be negative. Okay. Those who are watching it online, I would say you'll have to revisit this at least a couple of times. Write it down on your notes, and then try to explain it yourself, and then you'll understand the concept of pseudo force. So this is really important. Okay, and now if we analyze this free body diagram of the bag, including the pseudo force, we can say that sigma Fy is equal to 0. Why? Because there is no motion in the y direction. Why is there no motion in the y direction? Because the bag is moving on the trolley. So, on the conveyor. If I draw a conveyor here, the bag is moving along the conveyor and not to and fro like this. It is moving along the conveyor. So since it is not moving in the up direction or not is moving downwards, we can say that there is no motion along the y-axis, and therefore sigma Fy will be equal to 0. What does sigma Fy equal to 0 implies? It implies that forces acting upwards should be equal to forces acting downwards, and the forces acting upwards is forces acting upwards it's n, forces acting downwards is mg, so n is equal to mg. Now when we consider sigma fx, what else need to be included here? When we consider sigma fx, as we said earlier, we also need to include the pseudo force. And what is the magnitude of pseudo force? It is mb into AC. Now there is a mistake in this derivation. Okay, let me give you a minute. Will you be able to find out what the difference is, or what the mistake is? Exactly, the mistake is that the net direction of motion is towards the right. Friction is acting towards the right, which means friction would be taken as positive, whereas pseudo force is acting towards the left, therefore it has to be taken as negative. So friction here should be taken as positive. So this is positive Fk. Okay, so throughout the derivation it should be positive Fk, and therefore positive mu k. Now sigma means sum. There are two forces, one which is positive, other which is negative. So Fk minus F pseudo. What is F pseudo? Mb into AC. Now what is the Ma here? Ma here represent mass of the bag. Let me just write it down one more time. So the mass of the bag into acceleration of the bag with respect to the conveyor. Now let's see. What is Fk? Mu k into n. What is n? Mg. M, mass of the bag into G. Now throughout this equation, what is common? MB is common, so I can divide this entire equation by MB. So MB will get cancelled. So what we have is plus mu k into G minus AC is equal to acceleration of block with respect to conveyor. Now what is acceleration of conveyor? See, conveyor is moving with a constant velocity, and therefore the acceleration of conveyor is equal to 0. And since the acceleration of conveyor is equal to 0, this equation summarizes to acceleration of block with respect to conveyor as mu k into G. Okay, and If we apply equations of motion here, this is where we stopped here. Sometime earlier, right? We were trying to derive the relative acceleration. Now we have got the relative acceleration, so you can substitute the formula here, and when you substitute it, what you get? Minus 4 is equal to 2 into mu k into g. Mu k is 0.4, so it is minus 4 is equal to 8 into SBC. So displacement of bag with respect to conveyor is minus half, or otherwise minus 0.5. Okay, so this is displacement of bag with respect to conveyor. So why do we have the negative symbol here? We have the negative symbol here because this is the relative motion. Okay, or maybe let me just write it down here. So displacement of bag with respect to conveyor is equal to displacement of bag minus displacement of conveyor, which is equal to negative 0.5 meter, right? See, if A minus B would give you a negative value, it implies that A minus B is less than 0, or in other words, A is less than B. Similarly, if SB minus SC is minus 0.5, I can write this as SB minus SC is less than 0, right? And therefore SB is less than SC. What does it implies? It implies that displacement by the conveyor is more than that of the bag, and therefore the value is negative here. Okay, that was a pretty long explanation, because it was long because each and every word here is very conceptual and needed explanation. Okay. All right, having said that, let's move on to the next question, which actually is asking you to find the net contact force. Okay,